Imagine you're a detective at a crime scene. You're trying to figure out if the evidence really points to the suspect, or if it's just a coincidence. That's kind of what a p-value helps scientists do with their experiments. In simple terms, a p-value is a probability. It tells us how likely it is to get our results if there's nothing really going on. Think of it like this. The lower the p-value, the more surprised we'd be to see those results by pure chance. P-values are super important in research. They help us decide whether our findings are statistically significant. In other words, are the results strong enough to suggest that we've discovered something real, or could they just be a fluke? Before we dive into calculating p-values, we need to talk about the null hypothesis. This is a fancy way of saying nothing to see here. It assumes that there's no real effect or difference between the things we're studying. For example, if we're testing a new drug, the null hypothesis would be that the drug doesn't work any better than a placebo. Our goal is to see if we have enough evidence to reject this null hypothesis. Think of it like a court trial. The null hypothesis is like saying the defendant is innocent until proven guilty. We need strong evidence beyond a reasonable doubt to reject that idea and say there's something else going on. Let's say we want to know if a coin is fair or weighted. We flip it 10 times and get heads 8 times. Is that enough to say the coin is rigged? Let's calculate the p-value to find out. Our null hypothesis is that the coin is fair. If that's true, we'd expect to get heads about 50% of the time, but we got heads 80% of the time. Is that unusual enough to make us suspicious? To get the p-value, we need to figure out the probability of getting 8 or more heads in 10 flips if the coin is actually fair. We can use some math, or a handy online calculator, to find that the p-value is about 0.055. Section 4. Drawing the line, significance level. Now we have our p-value, but what does it mean? This is where the significance level, often represented by the Greek letter alpha, comes in. It's like drawing a line in the sand. The significance level is usually set at 0.05 or 5%. This means that if the p-value is less than 0.05, we'll reject the null hypothesis and say our results are statistically significant. Why 0.05? It's a commonly accepted threshold in many fields. In our coin toss example, the p-value, 0.055, is slightly higher than 0.05. That means we don't have enough evidence to say the coin is definitely weighted. It's possible we just got lucky with those flips. Section 5. P-values in action real-world research. P-values are used in all sorts of research, from medical trials to social science studies. They help us understand if new treatments work, if certain behaviors are linked to specific outcomes, and much more. For instance, imagine a study finds that people who eat a certain diet have a lower risk of heart disease. The p-value would tell us how likely it is to see that difference in risk if the diet has no real effect. If the p-value is very small, say less than 0.01, it suggests that the diet probably does have a protective effect. But if the p-value is large, say greater than 0.05, it means we can't rule out the possibility that the difference is just due to chance. Section 6. Keep in mind, p-values aren't everything. While p-values are useful tools, it's important to remember that they're not the be-all and end-all of research. They don't tell us everything about a study's findings. For example, a statistically significant result doesn't necessarily mean the findings are practically significant or meaningful in the real world. Also, p-values can be influenced by factors like sample size, so it's important to consider the whole picture. So, the next time you hear about a scientific study with statistically significant results, remember the p-value. It's a handy little number that helps us separate real discoveries from random chance.